Without question, memorizing every single bone and landmark of the skeleton is the secret to truly understanding the muscles. But here's the thing, it really doesn't need to be all that difficult. And in today's video, I'm going to show you two neuroscientifically backed techniques that will have you acing your exams in no time. And if you stick around until the end, I'm even going to give you something for free. There's a reason why it's a bad idea to try to memorize all 206 bones of the body one by one. That's because your brain's working memory, which is the part that holds information temporarily, can only handle about 4 things at once. Now this isn't 4 items, I'm talking 4 chunks. A chunk is simply a group of smaller pieces that your brain treats as one unit. For example, if you were to take the phone number 833-555-0934. At first that seems like a lot of numbers, because it is, but your brain doesn't really treat it like that. Instead it breaks it into chunks. You have the area code, the prefix, and then the line number. That is chunking in action. Neuroscientists have found that when you chunk, your brain literally rewires how it stores information. So early on when studying, your prefrontal cortex, which is the part you use for active thinking, is working overtime. But as patterns repeat, the hippocampus and basal ganglia starts compressing the information. It moves into long-term memory, and recalling the whole chunk actually becomes pretty effortless. This is why experts like surgeons or radiologists or even musicians seem to remember huge amounts of information. It's not that their brains are any bigger than yours, it's just that they've built richer chunks. So how is this going to help you learn and remember all the bones of the skeleton? Well, you don't want to just memorize it like a random list. Instead, you want to turn them into meaningful chunks. Instead of listing every bone, you want to group them by region. So the skull, upper limb, lower limb, and then within each region, you want to link those bones that move or function together. So like the radius and ulna or the pelvic girdle. So what you want to do is try to notice repeating patterns. So if we look at this humerus here, the humerus and femur are very similar bones. In fact, they're homologous, meaning that they're similar but different more or less. They both are going to have heads. They both have necks. It's not quite the exact same, but like the humerus has what's called the greater tubercle, where the femur has the greater trochanter, but they're going to have condyles, right? There's like when you start looking at these bones, you're going to start seeing that there's a lot of similar patterns. And this is this type of thing you want to really try to notice as often as you can, because neuroscientists call this unitization, and it's where you're fusing this stuff together, right? This information together, because it actually takes up less mental space. When you study, you want to revisit your chunks, not just the individual bones. So you want to test yourself by reconstructing regions or functions. So this is kind of like you're mentally building the arm from shoulder to hand. That strengthens the links, and it helps your hippocampus consolidate them into long-term memory during sleep. Now, I am all about mnemonics, but you really need to avoid shallow mnemonics. This is where you're like just building a mnemonic out of convenience instead of making it actually link to it in general. Like there's all sorts of different perspectives around mnemonics. I'm a big fan of making them super silly. That is also a really effective method. But this mistake I see students make all the time is they just come up with like these random mnemonics, and it's like that's just not going to help anything, because it's no different than trying to memorize just a random list. Like I just want you to picture yourself in a test when the context changes, like it's a quiz about function instead of order. That's just going to fall apart. So these chunks need to be meaningful. If the chunk is not meaningful, it's not really a chunk. It's just things thrown together, and you're kind of hoping for the best that they're gonna stick inside of your brain. All right, so now let's consider something else. If you've ever walked through a new city and then later remembered your way back, you've already used the same part of your brain that can help you learn anatomy. It's called your spatial memory system, and it's your brain's built-in GPS. This system lives deep in your temporal lobes, mostly in the hippocampus and entorhinal cortex. And together they build internal maps of space. So the hippocampus contains what are called place cells. These are neurons that fire when you're in a specific location. The entorhinal cortex, on the other hand, has grid cells that fire in repeating hexagonal patterns, and it gives your brain a coordinate system. These cells don't just help you find your way home, they help you mentally navigate complex structures like the human body. When you study anatomy, you're not just memorizing names, you're actually building a cognitive map. You're actually like traveling through the body, and you're noticing the different landmarks, no different than it would be in a city. You're kind of just like, oh, I recognize this, I recognize that, and you're building that spatial memory inside of the brain. The more you visualize these relationships, the stronger your internal map will become. I want you to think about it this way. If chunking is going to compress information, spatial memory is going to organize it. Your brain loves context. It remembers where something is far better than it remembers a random list. Okay, so how can you use this to remember the skeleton? I want you to imagine yourself physically traveling through the body. I mean, this is kind of like magic school bus type perspective. So like imagine you have your scapula, you have your humerus. When you're learning these things, it's almost like your focus will, here, I'll even put it this way. Like your focus comes on the scapula, comes on the humerus, they come together. You're just traveling in it. You're able to walk around it, look at it from all these different perspectives. That helps more than you could possibly imagine. That's because this activates the same hippocampal parietal networks that form navigational maps when you're walking around a city. And then your brain can also store information from two different perspective frames. So an egocentric perspective is from your perspective. And then an allocentric perspective would be from someone else's reference frame. And what you want to do is try to switch between them. This is exactly why you'll find multiple different ways to view a structure when you're studying on Kenhub. So it could be a cross-sectional view, a radiological image, or just a different perspective. You can even do this with your own body. So I want you to look down at your right arm, right? So if we look at your right anabrachium, so I want you to ask yourself, okay, which bone is medial, which bone is lateral? And then what I want you to do is try to imagine you are looking at it from someone else's perspective, and then ask yourself that very same question. Which bone is medial, which bone is lateral? Pretty soon you're going to start noticing that there are certain anchor bones, like the sternum, scapula, or pelvis, and those can become reference points to locate smaller bones, or ones that you just might not be as familiar with. Again, you do this when you're walking around a city. It's like you don't remember every single the structure. That would be crazy. Instead, what you're doing is like, I remember you. Okay, so then this other thing must be, yeah, there it is, right? And you're able to kind of piece it all together. And to make this even cooler, when you sleep, your hippocampus will actually replay these spatial patterns. It's kind of like your brain is rehearsing the route, and then that will help consolidate them into long-term memory. So if you study the skeleton in spatial chunks during the day and then sleep well at night, your brain literally rehearses the skeleton for you. I know this sounds simple, but I have been doing this with my students for years, and I can tell you it works way better than you would expect it to. So these two powerful techniques are something you should be doing right away. Now you're probably wondering, hey Justin, you promised me something free. I didn't forget. If you check the link in the description below, you'll find a 100% free Kenhub article all about learning the bones in the human body, along with a 100% free labeling sheet that you can test your knowledge with as many times as you need. And while you're down there, if you can go ahead and leave a like, hit the subscribe button, all that normal YouTube stuff, we would very much appreciate it. But thanks for hanging out with me, and I will see you in the next one.